So, recording started. Good morning again. Welcome to a webinar which I named Road Rehabilitation Made Easy. First, I will introduce myself. My name is Tomáš Nendvorský. I'm Senior Technical Specialist for AEC, working for Autodesk, based in Prague, in Czech Republic, but being responsible for Eastern Europe. We are doing this series of webinars for Romanian customers together with my counterpart Viorel Kun, and he will have some slot at the end to say something in Romanian because he is Romanian. However, the most of the webinar will be in English, or better said Chenglish, because my English is not let's say original one, but I believe that we can understand each other, and I hope that you will enjoy it. So all of you are muted. However, at the end I will give you a chance, or I better said I will answer the questions. So please, if you have any questions during the webinar, do not hesitate to type the questions. However, I will answer them at the end. So with that, I believe we set up the ground for webinar, and let's start. So if we are talking about today's webinar, so here is briefly agenda. First, quick introduction, what is road rehabilitation from Autodesk perspective. Then I will speak about workflow, which I will be showing during this webinar. And then we will go through each step of this workflow: planning, existing conditions, central line corridor, and report analysis. And as I said already, at the end of the webinar, there will be Q&A session, so I will answer your questions. And obviously also I will give floor to Viorel to cover his part. Okay, with that, let's start. So you can hear a lot today about building information modeling. So obviously building information modeling can have a lot of, let's say, perspectives. And today we will touch a little bit about BIM for infrastructure, and important part will be what we call dynamic model. Because if you look to road rehabilitation, and I will talk about this later on, obviously it is important to have one intelligent model, so one intelligent dynamic model, because it is in many cases tedious job. And what people are doing in many cases, they are having separate drawings for longitudinal profile, for cross sections. Then they are calculating volumes in. They are having it in some Excel sheet. Then they are making some changes. Then they have to redo, for example, if they do some changes in longitudinal profile, they have to make the change in cross section. Obviously, then they have to make changes in volumetric reports, etc., which is a lot of job, and obviously it is also source a lot of mistakes and errors. While if you have one coordinated, intelligent, dynamic model where all these parts are connected, intelligently connected, and if you change something in one part, then it's automatically propagated to the rest of the model, then obviously you have much more better coordination, and it will help you to really have control of the costs, because rehabilitation is usually with tight budgets and constraints on your side and also on the construction side, and it will ensure that you will have in-time delivery. And here I used very, I would say, rather old drawings: move the mouse, move the road, which in fact it applies very much to road rehabilitation, because what you want to achieve is that if you move, for example, longitudinal profile, then all the cross sections are automatically updated, all the volumes are automatically updated, all analyses are automatically updated, and you have immediately a response from the software what you did, and you can make a much better decision during the design process. So let's have a look what is road rehabilitation, what are the challenges. I put here something which I believe you are very well aware of. So as I mentioned already, very tight budgets, you have to meet standards for a defined road type, for design speed, pavement structures, and obviously you have too many constraints because you are already in existing conditions, on existing road, and moreover it can be in the side of the city where there is even more constraints with underground utilities, etc. And then designer must constantly prioritize multiple alternatives and what will be the subsequence of this alternative for the cost and the benefit of the design. And as designer, you have to often find a creative solution to meet the needs, because it is not like if you are building a road on a green field. Here it's much more complicated. It is much more constraints, as I already mentioned. And there is in fact no typical sections, because road is changing constantly. You have entrances, for example, to the houses, or entrances to the second road, so which you have to follow, etc. And many people are very often using as I already mentioned, CAD software, some drawings and Excel sheets, and combining everything together to have some results. And it's a very, very very time-consuming job, and you need to seek for a really exception to standards. And in this case, what we are offering is a solution where everything is tied together. I don't want to say that our solution is one-button solution where you will have a road design or road rehabilitation made on one button click. Definitely not. But what we are helping you with is this very simple and easy to use dynamic model where all parts are connected, and you will see immediately the results if you do some changes in one part of the design, what will be the subsequences. So with that, let's have a fresh start, and let's go to this next exit, and let's talk about road rehabilitation. And obviously, road rehabilitation, there are many different types, and we will not be able to cover all these types of the road rehabilitation. Sometimes you need to redesign entire alignment and profile to meet standards. You have to change super elevation because you need to improve design speed. Maybe you need to make widening, to change daylight, etc. Or some road rehabilitation is only resurfacing. So basically you have to mill, or better said scarify, the top of the road, put some overlay, but again with some existing condition with the constraints for entrances to the houses. And obviously you need to make sure that your design is cost effective, and also following standards as much as possible. Or it can be a mixture of both of above, so you are doing resurfacing, and at the same time maybe you have to do widening, and you have to create new daylighting. So what I want to say is that there is also a lot of different types of road rehabilitation, and what I will show you is a kind of mixture of everything. And I will try to show what are benefits and possibilities of our portfolio, Autodesk portfolio. So with that, let's have a look to the workflow which I will cover. So first, what is very important to make proper planning. And with that, I will speak about traffic simulation and the path analysis. Why? Because if you do some rehabilitation, so obviously the road or part of the road will be closed, which means that the traffic will be detoured, and they have to go other way around, which means that the traffic in the surrounding area will be affected. So we do have solution which will help you to analyze this subsequences of a road rehabilitation closure of the closed road, and you will see it in a minute. And also you have to realize that if there is detour, so maybe heavy tracks will go different way to the roads which are not maybe really designed for such heavy vehicles. So what needs to be done to check sweep path analysis to be sure that these tracks which are normally passing through this rehabilitated road can go through these side roads and they will not make damage on the city furnitures, traffic signs, etc. So then I will speak about existing conditions. So I will speak about classical survey, or I will also speak about point clouds, because this is also very good source of information how to start with road rehabilitation, because you have a huge amount of data, very precise data. However, you have to process it, and we will cover this as well. So then we will look to the alignment and profile. So I will show you what are possibilities of Autodesk products as far as best fit alignment and best fit profiles are concerned. So basically least square methods we are using to analyze the existing conditions, measured conditions, and to design the better alignment. Then we will talk about sub-assemblies, basically a typical road section which you can later on apply on the road. And you will see that we have a wide range of existing sub-assemblies which are very intelligent and which are dedicated for rehabilitation. And I will also speak briefly about sub-assembly composer, which is a tool which is helping you to design your own sub-assembly and to build sub-assemblies based on intelligence which you will put in, so basically based on your requirement. So, and with that we will after that we will build a model which we call corridor. We can start to edit it, to look at it, and at the end obviously we can make reports and analysis like cross sections, volumes, but not only this, so we can create what we call heat maps, you know, so how much is scarified in some points, how much overlay we added, if the cross sections are correct, etc., etc. So all these things we can do. So let's have a look to planning, what we can do with planning. And as I mentioned, if the road is closed, there are consequences. And the consequences are traffic jams, especially in urban areas. So, and what it means, not very happy drivers, and not only very happy drivers, but also pedestrians, etc. And what is important to understand, what will be the consequence of the road closure, and how the traffic will flow, and with that we have what we call traffic simulation, and we can do traffic analysis. And for this we are using Autodesk InfraWorks, and with that I will show you how you can tackle this issue. So what we can do is we can very quickly create a model. For example, here I'm in Timișoara, even though I have never been there, unfortunately. I hope I will be able one day. And with that I will create a model for free. I just have to wait a couple of minutes until I will receive this email message. Okay, this Timișoara model has been created for me, and I can download it. So I will click in the canvas to Timișoara model, and it was created today by me, and I will download it. Obviously, based on your connection, on bandwidth connection, so it can take half minute, 1 minute, whatever, to download it. But with that you have model of your place where you will do your rehabilitation, and not having any measurement so far. So, and with that what we can do, we have obviously roads, and then we can start to edit it. So here is the traffic, how the traffic will flow. And this is very important, because with that obviously you can later change existing conditions, because you will close the road, and system will understand this, and traffic analysis will not be able to go to the road which will be closed, and you will analyze it. And here in this example, what I'm going to show you is I'm going to compare both situations. I'm going to compare existing one as well as new one. Because obviously first I want to see what is the behavior of current and what will happen later on. So here I selected area which I want to analyze. So I just created polygon around my road closure, and I'm going to the traffic analysis panel, where I can start to create very quickly, for example, demands. Demands means I can specify which kind of vehicles will be passing, because obviously track is much slower than a normal car or SUV, and you can see I created here two divisions, normal traffic and construction traffic, because construction traffic means that there will be more heavy vehicles, and it will have obviously effect. And then what I can specify the demand. So basically I can specify the number of the cars traveling from point A to point B, just as a simple metric. So I have maybe measurement, or I have understanding what's going on. So with this very simple way I can define this number of the vehicles traveling in this area, and I can say, okay, which division, if it's the normal traffic or construction traffic, which I defined before, so depending how many heavy vehicles will be there. And then I will everything synchronize with cloud for calculation, and then I can start a simulation. So basically what I can do, I can have a look how it look like, and what it will be about when it is analyzed. So basically what I will do, I will close this traffic analyzed panel. I'm going back to my model, and I will run a simulation. So what system will do, system will download entire simulation from the cloud, and so I can start my simulation. So with that, by the way, we are consuming what we are calling cloud credits, which you are having automatically with subscription. However, if you are consuming more cloud credits, then it is in, let's say, basic package. Obviously, you can buy more. So, and then you see that we are fetching, or basically collecting this information from cloud, and with that I can start simulation. Obviously, here I'm not going to do very detailed, because you can specify, 10 minutes, 1 hour, depending how much. But now you can see what is the current flow, and you see, because I specified the number of the cars, also the percentage of heavy traffic versus normal traffic. So you can see that there is a flow, there is already some troubles at this point, but traffic is going so far so good. However, now let's go and let's have a look what will happen if I will close the road. So I'm going back to my traffic analyst panel. So then I created in fact a new one, because I want to compare it, I want to have both. So what I will do, I will define both again divisions, but I want to just copy it, so I am just copying through Excel sheet. So I will say, okay, normal traffic, construction traffic, and all this information which are necessary. I will copy and just paste, and I don't have to define it again. So just very simple. So I'm just copying. Maybe I could do only construction traffic at this point. However, I did both of them, and then I will also make demand division demands. So basically, again, metrics, and I already have all these measurements. So I will just copy paste the numbers to my metrics, and deal done. So I have all information, and now I will say, okay, now it will be construction traffic, because I have more heavy vehicles. So I will synchronize everything with cloud, but that's not all. Because what I have to do is I have to go and I should edit my junction, because here it's very powerful. So you can say which, for example, paths are barred, where is free float, etc. And then with that, I will just say that this part, now I'm talking about this part, will be closed, yeah? Because traffic cannot go with this direction, so traffic can go only this direction, etc., etc. And by the way, not only this, this is a very powerful tool. You can go much deeper. You can define traffic signs. So not only traffic signs, you can see it here, but also signalizing, basically traffic lights. So maybe there will be a red light and you can play that only half of the road will be one-way road, etc., etc. So there is a lot of combination obviously which you can try. And in fact, this is tool which is easy to use, and you can get and analyze very quickly this situation which will be happening. However, you don't have to be, and I'm not really a traffic analyst, and I'm capable of using it, having obviously some understanding what is the traffic flow, but with that I can analyze what's going on. And here I already shown where can be the trouble. So basically I shown the results, and in red areas there will be really trouble because people will be packing, and you can see that now this road here is closed, no traffic is going through, so people are passing only here, but it generates much more traffic going around. And here this road, obviously people want to go left, but they have to wait to the other people, etc., etc. So maybe the next step should be in this junction to make traffic lights, because so far there is no traffic lights, so that maybe I should put there temporary traffic lights and analyze it again. So to basically explore the options which what are the capabilities of current infrastructure, and basically to improve it to have better results if I'm closing the road. And obviously during the summertime people might be not very happy. So with that, let's move forward. We saw traffic analysis. And what about sweep path? So if you have incorrect sweep path and you are sending big vehicles somewhere where they are not really capable of turning, here can be the result. So basically the traffic signs can be destroyed, etc. So and cars and so on and so forth. So with that, what is I believe also important to check sweep path analysis. So basically what I'm going to show you the tool which is allowing to define vehicles, obviously different types of vehicles. We have also Romanian library already incorporated of design vehicles, but you can take, for example, some big articulated vehicle, and you can check how, if I'm sending this track to some area which is not usually used by heavy tracks, what it will mean. So if, for example, this island will not be destroyed, etc. So, and it has also consequences, because then maybe there must be a different detour for heavy vehicles and so on and so forth. Or maybe I have to make a temporary signage or something, basically to allow that these big vehicles will be capable of passing by. So with that you can analyze this, you can see what is happening and what will be the consequences. And also, for example, visibility sightline, because I want to know how far the driver will see, so I can do it here, I can do it in InfraWorks, in different areas, depending what I'm interested in. And basically then I can report it in the way that I'm creating pictures and I'm sending it to somebody who will make decision how to make the tour. So another important point which has to be considered before starting a real traffic, road rehabilitation. Another is how to collect existing conditions. I'm talking about survey. So if we are talking about survey, obviously there is classical survey, and we are allowing to bring very different types of measurement. It can be ASCII file with XYZ coordinates. It can be really survey from surveying machines. It can be CAD drawing, 3D CAD drawing with polylines, with 3D polylines, or it can be combination of both. I have 2D drawings plus 3D points in ASCII file, and I can combine everything together. And then the rest, what you can see here, are different analyses, because obviously I want to understand what's going on with existing surface. So we can produce a lot of different analyses like slopes to see if there are some mistakes or what is the current behavior, because it will make also good, it will set up also a good stage for road rehabilitation if I'm supposed to change crossfall because of the water or because of the design speed, etc., etc. So there is a lot of things, a lot of examples why I want to conduct very precise and in fact also colorful, but it's not only colorful but very important existing ground analysis. But what we can do also is we can use point clouds, which are coming from laser scan. So basically, if the road, if I have the data from laser scan and I want to start rehabilitation with Autodesk portfolio, you can do this, because we can take these source scans to Recap Pro, where we can process it. And we can also publish it to cloud, which means that other people can view it, so I can share it with maybe back with the surveyor if he is happy with that, or with some authorities. But more importantly maybe is that we can produce files which are later on shareable with our portfolio. So basically I can bring these point files to AutoCAD, Infraworks, Civil 3D, basically different products which we can use throughout the process. And not only this, maybe you will tell me, okay, but I'm not surveyor. What is the benefit for me, because I expected this? Well, in this case, we can do even point clouds from a device which I believe each of you have at least this bottom one, which means mobile phone or iPad. So basically what we can do is we can take pictures from the around some maybe important part. So we can take several pictures, or you can obviously use drones. And then we can process these pictures in cloud, because you will upload these pictures to the cloud. We will process it for you, and then we will give you give you possibility to download point clouds. And then the process is the same. So we have point clouds, and it's processed through Recap Pro, and we can use it within our products. So this is a second possible workflow. And this is in fact beauty and trends of our portfolio, because we can combine in fact both. So we can use laser scan from laser scans really devices and photos, and this is how it can look like. So let's imagine that you have very precise, for example, laser scan of the building. This is the example here. And then what you can do, you can import also laser scan from a drone. So basically we processed models through cloud, coming from just pictures. And then we have two models. And then within our portfolio, what we can do, we can combine both. So what you have to define, obviously in both you have to find at least 3 identical points. And then if you have these 3 identical points, so system will overlap to the proper coordinates both laser scans, or better said point clouds, into one model. Because don't forget, from laser scan you will get XY coordinate, from if you are doing some pictures only from your mobile device, not really. So you have to combine it, but within a really couple of minutes you will receive something like this, really nice, rich model. But if we are talking about infrastructure, then we have millions and millions of points, and what to do with that? So we do have tools to process these point clouds, so basically to have better understanding and better meaning of this, because it's very precise model but with a lot of points, and you have to somehow process it. So what we can do is we can as it already was here, you know, so we can process it through recap. So we are here, so we can combine different files, so we can put it together, and we will receive a model. Yeah. So we have model combined from different points clouds, and now I can start to process it. So maybe I selected only part of it, I don't need everything, and I'm bringing this model into InfraWorks. So I'm just importing this recap point cloud RCP into the model, and I can start to process it. And we can create from structured point clouds, we can create terrain model, basically thin triangulation. But also what you usually have are some vertical objects like trees, lamp posts, traffic sign, etc. So what we are offering, so basically this is filtered out, automatically it's filtered out. But what I want to achieve is I want to have it as an object, not as a point cloud. So we have a semi-automatic way to put objects and to replace these parts of the point cloud with really object like point cloud, traffic sign, to have really much better understanding of model. And obviously, as I said, it's a semi-automatic, so system is recognizing what is this and proposing you different types, and then you have to make some changes, slide changes, you know, to put it in proper location. So, and that's not all. Because if you are talking about, and we are going to the core of road rehabilitation, we have point clouds of the surface of the road. But there is, as I mentioned again, it's millions and millions of points. So what we would like to have, what we call feature lines. So basically lines or 3D polylines, we call it feature lines, but we can call it 3D polylines, which are following, for example, curb, center line, edge of the road, and all this information. And we have tool which is basically allowing you either automatically or manually detect this. So basically now I'm going to the center line, I'm clicking on 2 points on center line, and then system will create the feature line for me along the entire entire length of this feature line of this center line, basically where it's recognizable. Yeah. So basically depending if there is really at this point really feature line, because sometimes this can disappear from measurement, etc., etc. But we do have tools which is doing it automatically, and then if it fails due to some reason, because as I mentioned, so maybe there is change of super elevation and this center line is kind of disappearing, so maybe you have to do it manually. But what is important is that later on we can even edit it in cross section. So basically if I see some discrepancies in cross section, so I have cross section, I can change it in cross section. So basically I have really correct and proper line which is representing curb, line, center line, edge of the road, etc. So, and you can see that I have different colors, so I can colorize it based on the type and so on and so forth. So you can do it, you can modify it, and you can do, for example, with that process, for example, electrical overhead lines, you know, so that kind of stuff, it can be also recognized and you can work with that. And now, if you have these lines, which are important later on for me, so what we can do, we can export it and bring it to our next tool, which we will be using for a really detailed design, which is Civil 3D. Yeah, so we can export it to shapefile and we can bring it forward. So, and then this is what we can do in Civil 3D. So these feature lines which were extracted here, so this shapefile, so we are capable of bringing to Civil 3D, and then in Civil 3D to create a surface if I don't need, for example, this point cloud surface, or we can make combinations. So it's entirely up to you what you want to achieve, and how you want to deal with that. And at the background we are using, now I'm using some US-based coordinate system, but we are based on map 3D coordinate system with all European objects, including Romanian coordinate systems which are available. Yeah, so basically importing this shape file, so bringing it as a in this coordinate system which is defined in the drawing. So here you would define your Romanian coordinate system, bringing it in, and you have it. And obviously you can also draw pictures of the existing ground, etc., etc. And you can start to process it. You can create triangulation, and you can work with that. So with that, let's move to centerline. What we can do with horizontal centerline. And if we are talking about centerline, and if we are doing this, let's say, design speed improvement type of rehabilitation, basically what I want to achieve is I want to have a new centerline with new parameters. So basically I want to have information where is straight, where is curve, where is transition, etc., etc. Because for some type of rehabilitation it's important. So I'm creating alignment called rehabilitation, and what I will be using is a tool which we call best fit. Best fit means that it's based on what is also called least square method. So least square method is mathematical procedure. From given coordinates we will calculate either straight or curve with minimum distances to the resulting line. And as you saw, I can pick up points, I can pick polylines, I can pick lines, whatever is available and whatever we can do. So, and with that, I'm just picking points, and because I'm defining lines, so I can see, okay, maybe this last point is maybe too much. So what I can do, because I have offset, which you see too much, 80 centimeters, just forget about this, so I want to exclude this point. So basically I just pick this point, but finally I realized, okay, I don't need it. I can also define pass-through point, because maybe you have some bridge, small bridge, which you have to follow, which will not be redesigned, so you can pass through. And the similar things you can do with curve. So you can see that using again the least square method, I'm defining points, and this is in fact floating curve, which will be attached to this previous curve. And I can see again the distances between new curve and original point, and I can play with that. Basically I can create this centerline the way that I need. And then we can move to profile. So basically the same situation. So I already draw here profiles through existing ground, which is on this right hand side, and now I'm creating a vertical profile based on same method, basically least square method or best fit analysis. So basically again I am picking points, so I can click lines, polylines, and system is creating a profile for me, best fit, and you can see that it's automatically drawn in this profile view, and I have immediately understanding how far I am vertically from existing surface. So because maybe I want to see how far I am, because if I click, for example, maybe next point, I will start to be too far and I will not be too happy about this. Yeah, you can see it, so point is there, but my slope is going somewhere else. And again, the same procedure, I can exclude points, I can define pass-through points, as again if I have some bridge or something which will not be reconstructed. So I can play with that to have best results. So I can save it, I can close it, and I can continue. Maybe I want to continue with curve again, best fitting floating curve. It will be floating to this slope, and again I am adding points, and you can see immediately I have response in, maybe I forgot this point, so I can, it doesn't have to be really in order, you know, because obviously there is a clear understanding what is the chainage, and you can see what's happening. And you know, here we are finding best fit, but at the end you can go, and this is fully parametrical alignment and profile, which can be later on changed using standard functionality. What I want to say is that you can do some parts using standard functionality of AutoCAD Civil 3D, sometimes with this best fit solution, so you can make combination as desired. So because sometimes some part of the road is like improving design speed, some part is only this resurfacing, etc. So you can play with this and you can achieve what is needed. So next one is to build corridor. So we have alignment and profile, we have existing conditions, which mean triangulation. So let's have a look what we can do with corridor. Before we build corridor, what we need is subassemblies. And there are, you see, rehab subassemblies. And these subassemblies, and I will not go to the very details, but you can specify here, for example, overlay depth. You can say how much is milling, what is the amount of milling required, you know, and so on and so forth. You can follow some slope, some calculated slope, with overlay, without overlay, and you know, a lot of different combinations. You can define minimum clearance because you want to add some material here, and you want also achieve some minimum clearance because you know that this road is not very good and you need to add something, at least, for example, a couple or 5 centimeters of new material. So you have all this information or better said possibilities available. Yeah. Or what we have is subassembly composer, which is possibility to build your own intelligent subassembly, which is based on some decision-making process. And you can see here decision, if then, if something happens, do something else. So it's kind of visual programming, but very easy one. To learn something like this, it takes a really short time, and then you can build really subassemblies based on your requirement. And here you can see that we can use linear regression analysis as well, so basically kind of best fit in cross-section, etc., etc. So a lot of different possibilities available in Civil 3D. So let's have a look how we can build corridor. So what I did is I created here assembly, and within this assembly I used intelligent overlay, mill, and level 2, basically one of the subassembly which is allowing you to define, you know, how it will be behave. And the behavior can be like that you can leave your road kind of cross-section flipping. So basically you can allow the system to change crossfall in some limits. For example, I set up 0.5% and I said to system, okay, please change 0.5% of crossfall based on minimum cost. So basically I'm immediately improving, let's say, cost effectiveness of the solution, because system will automatically change crossfall if it's not required. Maybe I don't need 4% of crossfall, and system will do 3.5 because it's better as far as cost is concerned. Another possibility is, and you can see it here, because I have constraints. Basically I am doing here just I have to follow the existing width of the road, so I am picking up existing edge of the road left and right, and again they can come from classical survey or for point clouds you saw there in previous part, and I can create very quickly my best fit cross sections. And also I want to make some widening, because the part is that, okay, we will make a resurfacing of existing road, but we will add some another layers. And the story is that now what I want to achieve, because crossfall is changing, and now these new layers should follow crossfall which has been calculated in previous level, in previous step, better said. So what I'm telling to system, okay, now follow the surface which we created in previous step, which is coming from this road rehabilitation, and add or widen it based on this crossfall. So again, I just pick up some, I believe, interesting tool which will allow you to make widening and not really necessarily calculating each and every crossfall and you know, adding these new structures, new road structures. So everything will be done automatically. So, and I'm creating, I created this subassembly, and now I will add this as a new corridor. So I will my design will be combination of several corridors, because this is for me at this point the best solution. And obviously I can specify the targets, I can specify what will the frequency, how often system should calculate all these values, and I also will tell to system, okay, where to start. So basically what I did, I extract it, and everything is dynamic, so I do it once and then system will do everything if I do some changes. So I kind of extracted this edge of new road, not only horizontally but also vertically, and system will start to do this. I mean the new widening, and I will rebuild corridor, and you see that I added another layer, or better said width, with different layers. Yeah, so, and you can start to do it for left, right, etc. And now I will just show you what I did in cross section. So I'm creating at this point one cross section, and just let's have a look in cross section view how it can look like, or how it looks like, not how it can look like. So you see that I have my road, and what I did, I didn't include it all sections. So basically I have to include both corridors, just to show you that if you forget anything, don't worry, don't hesitate, system will edit, or system will edit if you tell it to him. And you can see I have crossfall, and based on this crossfall, and this crossfall is again automatically matching the current crossfall in some limits, and I'm adding widening with full, let's say, structure of the road. So you can see it as a example what we can do. And now, now let's have a look to report and analysis. And now this is start to be, you are getting most of the benefit, because as I mentioned at the beginning, what is important, move mouse, move road. Basically, if you change something, that will be automatically propagated. And in our case, everything is connected. What I'm talking about, interconnection between layout, horizontal alignment, vertical alignment, cross-section, volumetric calculation, and everything is connected. If I change something in one part, it's automatically propagated to the rest of the model. And this is where this tedious job, which is which needs to be done, in fact, during the road rehabilitation, we are partially helping you in intelligent sub-assemblies. But again, you are designers, you want to have full control over the design, and then we are allowing you to make changes maybe in one cross-section, in a couple of cross-sections, because it will better fit the design, etc. So with that, I will show you what can be the results. So, and here I already created a drawing based on Romanian country kit. So I have this overlay and milling. So basically you can see that I have to first mill part of the road, and then I will put overlay, this additional layer, so it can be different materials or it can be the same material, but I want to calculate separately milling as a volume, how much they have to scarify or take away of existing one. And now I'm showing you that everything is connected, because if I change something in subassembly, it will be automatically propagated to the rest of the model, to the, in fact, cross-section in this case, cross-section view and volumes. So, and now I'm telling to system, okay, now I'm using this design profile. But what we have, for example, possibility, use minimum clearance. What does it mean? System can, if you go to help, you can check it. So we have functionality built in a subassembly that we can calculate the profile based on these criteria. So I will not go very deep into this, but basically we can find the best point for the profile, and you can interrogate what will happen if you do use this functionality. And now, in fact, it's my habit. I am not rebuilding everything automatically because I'm doing some changes, and I want to see maybe changes after a while. So now you can see immediately that when I calculated something, it was not only cross-section view was updated, but also volume. And then again, I have left and right corridor separately, so I can rebuild both of them on request, but you saw that I can do it automatically. It's really up to you, and everything has been calculated. So all calculation has been done. I don't have to look after that. So another possibility is to create what I call heat map. So now I can see, for example, difference between existing surface, top of the road, and existing existing surface and new top of the road. Sorry for not being clear from the very beginning. So, and here we have immediately understanding how much we will be adding or taking away from the existing one. Because what I did some model which is in fact different comparison between two models. And you can see, you can compare different model. Maybe you have model before scarification, after scarification. So it's really again up to you, and you can bring as many models or as many surfaces as you wish. Yeah. And now what we can do is we can change something. So now what I will do, I will change this subassembly, just that you see that if I change something, it's also propagated automatically to the rest. And now I will go back to this previous solution. I will use profile. I will rebuild corridor and see what will happen. So look that the scar scheme obviously will be changed because it is different using design profile or this, let's call it calculated profile. And you can add also, for example, labels, because I want to see what is level difference in one spot. So I will select the surface, I will select the spot, and you see that elevation level difference is 13 centimeters. And again, it's dynamic. Moving this, you can see that the number is changing because obviously the difference, level difference between two models is different in different places. So again, another way how I can analyze my model, I can see cross-section obviously, or I can analyze it this way that I have all the function, all the elevations and everything here. Yeah. And also what we can do is we can create, and now I'm searching where I put it, so I put it here. Yep. I created tables. So basically I have tables on right hand side. You can see I have table tables for of the volumetric calculation per cross section. But now what I want to create is one table for entire design, and I have separately overlay and separately milling. And again, you can, it obviously it can be different models. And again, what I want to show you is dynamic behavior. So if I change, for example, default, again, going because it's getting much bigger differences, so it's automatically will be automatically rebuilt if already said updated if I rebuild model. So you can see that then from 587 cubic meters for milling it is different. So again, immediately you can see the consequences what's going on. And here I have a profile. standard, let's say, profile according to standards, but what I want also to see, and I created here new band on the top. So just here I want to show you that if you are using Romanian country kit, obviously you can choose different labels, and now I will use some label, and now you see that I'm not very good in Romanian because in fact I'm using the same one, so no changes. So I made slight mistake with my lack of knowledge of Romanian language, but now I can import it, different one, this style which is defining or better said annotating a vertical profile different way. And here I have level difference between existing profile and design profile, and again it's just different way combining information, and you see that I have here one profile and second profile, and here on the top, and it's just example, it can be bottom, wherever you want to have it, and I have immediately understanding what are the level differences. So a lot of functionality which is helping you really to analyze the design and make the changes as required. So with that, 1 hour is gone, and before the questions, what I will do is first I will make a VRL presenter, and VRL floors is yours, and I will check the questions in the meantime. Yes. So VRL, I believe.
Tomasz, I don't want to show anything. I just want to.
You can hear me, right? Yes, I can hear you. I hope that the rest of the people as well. Yep.
Okay, so I don't want to share anything. I just want to thank you for the webinar and just say a few words in Romanian. Bună ziua, în primul rând. Mulțumesc frumos că ați participat la webinar. Dacă aveți colegi care nu au putut participa, o să înregistrăm webinarul. Webinarul de fapt este înregistrat și vom trimite o copie video după webinar. Vreau să vă spun că facem webinariile ca să fim în continuu dialog cu dumneavoastră. Și dacă mai aveți orice întrebări, nelămuriri, atât pe partea tehnică cât și pe partea administrativă a licențelor și așa mai departe, atât noi ca Autodesk cât și partenerii noștri din România vă stăm la dispoziție. Vă mulțumesc frumos. Tomasz, the floor is yours. Again.
Yeah, okay. Thank you. So I was just checking in the meantime questions. So at this point there are no questions. So please, if you have any questions, please type it in, because it will be easier for me. Because if I, yeah, please go ahead and type your questions into the questions area. Is it, so here is the question, is it hard to go from AutoCAD to Civil? Well, not really, because you are based on AutoCAD. Obviously, Civil CD has much more functionality, which is allowing you road design and road rehabilitation. However, I would say that if you are used for AutoCAD, you are using the same commands, snapping points, this and that. So if you know AutoCAD making drawings, so it's very easy for you. And we are also helping you with what I already mentioned here, Civil 3D Romanian country kit, so having drawing according to standards. And then what is needed, obviously, to learn what are the Civil 3D objects, how it behaves, and how to create it. But I don't consider it as a very difficult one. Yep. Any other question? And obviously, maybe what I should stress, we do have our authorized partners which are authorized to train you in particular functionality, and they will be happy to assist you also not only with the training but with the first pilot projects to let's say, help you to drive through this process and to have as smooth transition as possible. Some other questions? I mean, if you have some questions and you have the feeling it would be easier to type it in Romanian, please type it in Romanian, and I believe Viola will help me. Okay, here is if we will make a webinar available. Yes, it's recorded and it will be made available to all of you. Okay, if there are no questions at this point, I will conclude this webinar. However, if something will pop up to your mind, please you can contact me, tomas.lendvorsky, monkeyautodesk.com, or Vigora will contact you. So please do not hesitate to ask us, and we will help you to understand even more about our solution. With that, thank you very much for your attention, and I wish you a nice day and the rest of the week. Thank you. Bye-bye.